Good morning, Professor. My name is Gauri Shankar Chintala, and this is my teammate Sahiti. We are excited to present our project titled Building Intelligent Domain-Specific Chatbots Using Advanced RAG Techniques. This project explores the power of Retrieval-Augmented Generation, which is known as RAG, to create highly effective and context-aware chatbots.
Together, we have worked on designing and developing a chatbot that combines cutting-edge technology with a simple and intuitive user experience. Let's dive in. So, our project focuses on creating a chatbot that retrieves and generates responses based on external knowledge. This makes the chatbot highly adaptable for domain-specific queries. We aim to solve key challenges like accuracy, context retention, and user engagement through RAG models.
Throughout this project, we implemented a user-friendly interface and evaluated the system's performance on real-world datasets. This presentation covers our journey findings. Let's start with some background. Over the years, chatbots have evolved significantly. Traditional chatbots were limited to predefined responses, while modern ones leverage AI for dynamic and intelligent conversations.
RAG represents the next step in this evolution. By combining retrieval and generation, it enables chatbots to answer complex queries more accurately by pulling data from external sources. The objectives of our project were clear. To develop a chatbot capable of handling domain-specific queries, here our chatbots read a PDF file and generate responses within the file data. To leverage RAG for enhanced accuracy and to create a seamless user experience.
The ultimate goal was to demonstrate how RAG models can bridge the gap between static information retrieval and the dynamic response generation. This slide highlights the key differences between RAG and non-RAG models. Non-RAG models rarely solely depends on training and often limited their accuracy. For example, response accuracy in RAG has higher accuracy with up-to-date information, but non-RAG models are limited for their training datasets. If being domain specific, it can be highly specialized to a particular domain, but the non-RAG models were like limited to their general knowledge.
Yeah, that makes us our chatbot, our RAG chatbot, to provide accurate answers. In contrast, RAG integrates retrieval mechanisms, allowing the model to fetch relevant information from external sources, as I've told earlier, and generate context-aware responses. This makes RAG a game changer. Going to the next slide, here is an overview of our methodology. We implemented advanced text splitting strategies, vector databases like FAISS and Quadrant, and large language models such as MetaLlama and Mistral.
So these are the steps we used in our methodology: data ingestion and preprocessing, embedded generation, vector database integration, query processing and retrieval, and language model integrations. So we are using two different databases for our vector databases, and we are using some LLM models which integrates with the databases and give our output. Let's switch to a code for a second. Let me
Let us show your function how we handle the splitting and all.
So this particular function load doc, which takes the document, the PDF file which you upload. This function handles document processing. We implemented strategies like recursive splitting, which ensures the overlapping chunks for better context. This step ensures the effective handling of lengthy documents. Coming to chunking, so we are using three different type of chunkings: semantic chunking, recursive chunking, and fixed chunking. And these are the two databases which we are using: FAISS and Chroma DB. And these are the two language models which we are using. It's Llama 3.1 and Mistral 7B. Sorry. So why we are choosing these two particular models? So these two particular models are like mid-range, which are not too large and not too small. So we are not choosing any large models because we have an hardware issue where we can't run those models completely with our 4 GB RAM laptops. Instead, we are using this Hugging Face virtual space, which provides us 16 GB of virtual RAM and also a good processor in our free tier. So we have deployed our project in this. Let's go to dataset. Oh, yeah. Our dataset includes domain-specific documents uploaded by the user, and these documents are processed through RAG pipelines, where relevant chunks are extracted from answering queries.
So the pre-processing steps ensures that the chatbot has access to well-structured, meaningful data, enabling it to provide precise responses. Yeah, as Shankar explained earlier, we have explored various LLMs and chose only these two models, Meta-Llama and Mistral, for their superior performance in handling domain-specific tasks.
Let me show you code for.
Initializing.
So this particular function is to initialize the database, whichever we select in our web app, it's gonna initialize that particular vector database, and this one is for initializing the LLM model. This function ensures that we can fine-tune the model's behavior by adjusting the parameters like temperature, token limit, and providing flexibility for different tasks. Alright, let's leave it right there. Let's go to next one.
Metrics.
To evaluate our chatbot, we used metrics like accuracy, latency, and user satisfaction. These helped us measure how well the chatbots can perform in real-world scenarios. Here, EM is exact match, and F1 score evaluates the overlap between the prediction and the true answers, balancing precision and recall. Rogue 1, Rogue 2, Rogue L, long comments subsequences, and answer length, which depends on our report. Let me show you my report. So we have used this particular dataset for checking our accuracy, which is Squad 2.0 dataset. Here, this was like it's a GitHub repository which has a dataset and also question and answers. We have automated a code to generate our to check whether our model's accuracy is good or not. So here this is one particular combination. Let me show you our web app first. So this is our web app. So our interface is very simple. Any user can understand it. First we have to upload the file, and we can select whichever database we want and the chunk size and also the strategy. After creating our vector database, we're gonna select any LLM model, and here we can select those parameters which I've discussed earlier. I can select token sizes and also set the temperature, which depends on how we want the data, how to improve the accuracy. After initializing the LLM model, I can ask a question to my chatbot, and it will definitely give a good response. Let me go to after.
Yeah. So
This is our experimental setup.
So this our experimental setup involved rigorous testing and various document types and query complexities, ensuring the chatbot's robustness. In our experimental setup, we have different chunk sizes as we have mentioned here, and there are vector databases we can choose from, and the chunking strategies we can choose from, and the language models as well. So here we have demonstrated the features of our UI. The UI is built using Gradio, designed for simplicity and interactivity. Users can upload their documents, configure their settings, which I have mentioned earlier, interact with the chatbot in a few very easy steps.
Cool. So let me show you that function real quick. I've already scrolled to it. So this is our function where our user face relies. This code initializes the UI, and each component such as file upload, LLM initialization, and selecting databases, which is all linked with the backend functions for real-time interactions. To sum up, our project demonstrates how RAG models can enhance chatbot performances by integrating retrieval and generated capabilities.
Yeah, this approach not only improves accuracy but also opens new responsibilities for domain specific applications, making it a valuable tool in various fields. Now, let us show him how our chatbot really works and what are the
Yeah, let's do that
needs
first.
to do that.
So let me refresh this real quick. Okay, it's running. Okay, let me upload a file. Let's go with this file, which is Sahiti's previous OS project one.
So I've
And
basically
I'll
worked
select,
on research on Android OS for the automobiles.
and this is the splitting strategy I'm going with, recursive, and I'll go with FAISS, and I'll go small chunks. So this will take some time because we don't have any good hardware capabilities. It's just a uh, basic hardware in this particular code space. It only offers 16 GB of RAM. Usually, this kind of models need at least 32 GB to ensure fast processing and better performance.
Yeah.
In the meantime, let's discuss about this future work.
So in the future, we plan to extend the chatbot's capabilities to support multimedia inputs and explore more efficient retrieval mechanisms.
Additionally, deploying the system on larger real-world datasets will improve further insights into scalability and performance. Here we use this particular uh, dataset, but we can use a few. This is like a testing dataset for AI models. We can use a real-life datasets, which will provide very good. Uh, it's very useful for us. So yeah, it was created, database created successfully using recursive splitting and FAISS vector database, recursive and FAISS. So I'm gonna select this particular model. Let's see what I'll initialize that model. It was preloaded and it was really quick, cool. Let me ask a question. Okay, what is this document about? This document provides an introduction to Android OS for automobiles, including its historical perspective, goal, characteristics of the safety, and the platform that goes into generating Android OS. That's pretty much what Saiti worked on her last semester.
It really gave the accurate answer.
So let's see how our model is retrieving the data. So it took after chunking, it took from 3 different chunks, which is introduction and few other chunks from page 3, page 2, and page 10, and it retrieved this particular information. It doesn't give the exact paragraph as an output. It usually generates its own text. That makes this RAG chatbot unique. You can't, if we copy paste this one, we can't find it in our document. Let me ask one more question for this. Okay, let's go with what are pros and cons of this particular document. The advantages and also disadvantages. If you can see, there are it's not like displaying any points. It's just making a paragraph on its own, and it gives the all relevant information. And now it used page 13, 14, and 13, these 3 chunks to retrieve our data.
Yeah.
Okay, let's go back to our PPT.
And let us also show what are the chunking strategies and our experiments. What we do.
So there are many different types of combinations where we can. So these are all combinations we can go through. So using Mistral model, and also using FAISS, and also using Chroma and Mistral. And what kind of strategy? So let's say these three were related to Mistral and FAISS database, but the strategies are different.
Yeah.
So there are like 12 different types of combinations. We tested 7 so far, and it was taking so much time to generate a report because uh, our hardware is limited. So this was the report for Chroma fixed size, and using this particular Chroma as a database and fixed size strategy, and using this particular model. And if you can see, chunk strategy is this, and LLM model is this, and this was the question which we asked, and this was the context of that question, and this was the answer which is supposed to be given out, and this was the answer which was generated from our model, which is same, and it was an exact match. So F1 score is 1, and rogues are also 1, and ground truth is 2. So it was clear it's a clear answer, it's an exact answer.
Yeah. The accuracy you can see here.
You can find the accuracy. Yeah, let me show you my report real quick. Yeah, over here.
That's the summary.
So this is the summary of our report. So we are using this fixed size 500 chunks, and LLM model is this one, and this one is the database which we used. We have mentioned all our reports in our paper. You can find it right here. Our paper briefs about everything. It has everything. So these are the results. You can find everything here. How accurate our models and how accurate our chatbot is. Alright, so let's go. I'm gonna close this one. Don't save. Let me pull this one real quick. Where is this particular? Yeah, these are all iterations we've gone through. We so far, like, we checked for 7 different combinations in those 12, and this was the outputs which we got. I mean, everything. Let me show you another one. This one is fixed. Let's go to FAISS and recursive. Here is this. So this particular summary, which says we used FAISS database and we used recursive strategy and used this particular model, and chunk size is 500 minimum. Overall, you can see our scores. It was like 80% accurate.
Yeah, when compared to the
When
squad data set,
Yeah, we used squad dataset for this particular report. We can use some other different data sets, but we found this one is an open source, so it's easy for us to go with that. Let's go to our PPT. These are the references. We also mentioned few references in our paper, which we all checked. These are all the references which we've gone through to finish our project.
Yeah, we have just entered only a few in the PPT which are more highlighted, and we have used much while developing this project.
Here we've simply used some ground libraries, which are open source, to execute our chatbot. I've explained this all, right?
Yeah, initializing the database.
Yeah, and this is our.
Yeah.
These are all combinations. Yep. So overall, our project provides a very good detailed overview of the question we asked in that particular PDF.
Yeah, it gives pretty accurate results and very quick.
So
Yeah,
thank you so much, Professor. It's been a pleasure, and we've enjoyed a lot during this process because this RAG is new tech. this is new technology in market right now. I mean, people are still trying to develop RAG models and RAG pipelines, and we are so glad and proud of ourselves for doing this particular project, because we got an exposure to very good, very few insights which we don't know about, and that was so good. I mean,
Yeah, we really think it has a great edge in developing any future developments on this RAG model, because it's still an upcoming technology. So, and we have really excelled our skills while developing this project. Thank you so much for this opportunity, Professor.
thank you so much for the opportunity, Professor.
Yeah, have a good one.